You are now listening to the Add 10 Gallons Concrete Podcast.
Wait, the answer was add 10 gallons?
Add 10 gallons.
My first thought was we got to put Aggregates in it.
Yeah, great.
Truck's on the way. On the way.
Yeah, okay. I've got two observations, neither of which are really educated or well thought out. Which are like most of my observations are.
There aren't a lot of problems at a job site that can't be solved with a sack full of biscuits.
Today's episode of the Add 10 Gallons Concrete Podcast is brought to you by Actigel 208. Actigel 208 is a high-performance additive for the concrete industry that is greatly beneficial to the producer. It enables them to increase the percentage of manufactured sand by up to 100% and completely replace all the natural sand in the mix. In areas where natural sand is scarce, inconsistent, and expensive, this provides a huge benefit to any ready-mix company out there. Benefits of manufactured sand and concrete include consistent air content, improved compaction, and increased density. Now, in the past, the downside of using manufactured sands was that they were hard to pump, hard to place, and hard to finish. Well, Actigel 208 solves all those issues. By improving suspension, stability, and the quality of the cement paste in the mix, Actigel overcomes the old issues with manufactured sand and leaves them behind. Let Actigel 208 improve the quality of your mix while saving money on every yard you produce. For more information, visit us at actigel.com. That's ACTI-GEL.com.
All right, everybody, welcome into the Add 10 Gallons Concrete Podcast. This is episode 3, and if you're here for episode 2, we appreciate you. If not, go back and listen to it. We had Mason Guarino on the phone from South Shore Gunite, talk about all the intricacies of that business and what he does in his family-run business, and it was a great conversation. He's a great guy, be awesome to work for. How invested he is in that business is definitely something to aspire to for sure. But we have a new guest on today. We have Jim Casilio from the Pennsylvania Aggregates and Concrete Association, otherwise known as PACA, and he has a great perspective on what they do and the political aspect, how the state and the federal work together. So I'm interested in hearing that. He'll have some good stories, has a fantastic amount of experience, so it'll be a great conversation, and we're looking forward to it. But in the meantime, we got the boys back. Paul, how's it going?
Oh, man, go get it. Excited to hear about this study you found.
Yeah, for sure. Joey, how you doing?
I'm doing excellent, fellas.
Good. Yeah, and what we were just talking about before we went live here, a study I was just reading from MIT, essentially, with a little bit of help from the Concrete Sustainability Hub there at the Portland Cement Association. I think they also tapped the Ready Mix Concrete Research and Education Foundation. Principal research scientist was Jeremy Gregory there at MIT, and they came up with a study basically saying stiffer roadways will improve truck fuel efficiency. And we're thinking, duh. But they talked about the amount of deflection that a truck will build going down the road, and basically it's an uphill climb the entire time, especially on softer roadways, being asphalt or even older roadways, whatever it may be paved with. The vehicle is constantly in just a little bit of a ditch, a little bit of a lull there that it's trying to get out of. So stiffer roadways could improve fuel efficiency and thus reduce carbon emissions. And basically what they say that got me excited was we need to start paving more roads in concrete. And we can get into all the reasons why they don't currently, but at the end of the day, by changing just anywhere between 2 to 10% of roadways to quote unquote harder roadways, and in this case certainly concrete, it'll make about a 0.5% difference in the amount of transportation related carbon emissions that are made today over the next 50 years, I think, is how far out the study went for. Now they also said that you can make asphalt roadways stiffer as well, with the addition of fibers, carbon nanotubes, things of that nature. But, as you and I know, anytime you increase the cost of asphalt, it's kind of counterintuitive because it's a low dirty material made with recycled products anyway. So, this study was really cool, and, we've been saying it forever, and hopefully a lot of people listening to the show have been saying it forever. We just need to pave more stuff with concrete.
Yeah, that's a big initiative right now with the NRMCA. They're talking about paving nonstop and talking about how it's not only is a superior material to asphalt, but it no longer costs more. And I think Joey knows a little more about that. I mean, that paving's his background. What do you know about that, Joey?
Yeah, especially when you get into like RCC, roller compacted concrete, it's placed very similar to asphalt, as in they use basically the same equipment to place roller compacted concrete as they do asphalt. They use dump trucks to deliver it. It's placed with an asphalt paver, and they roll it, with a roller. So the main difference would be probably labor. I would say there's not as much labor with concrete as there would be asphalt, because you guys know, you see a asphalt paving going on a road, there's 20 guys standing around there, where roller compacted concrete or even slip form paving, they're all on machines. There's not much labor going on. So I think that's a big difference. And also the material cost. If the machine and equipment cost is the same, then it gets down to material cost, and roller compacted concrete's got to be getting down there pretty cheap.
Yeah, well, it didn't used to. I mean, the prevailing sentiment 10 to 15 years ago was that the concrete paving was about 2.5 times more expensive than asphalt paving. And so when these projects would be on state level and they'd be up to say, okay, which one are we going to do? Are we going to do the asphalt that needs to be repaved every 5 to 7 years? Or are we going to do the concrete that needs to be redone every 20 years? Well, long term, the concrete makes total sense. But unfortunately, we're doing budgeting cycles with governors, and the governor's terms are limited. And so they've only got so much money in their bankrupted states, and they say, well, I'm going to go with the cheaper option. So time and time again, when these projects come up, people are choosing asphalt. But now what the NRMCA is saying is that information is old. That was 10, 15 years ago. Now we got new methods. Joey just talked about RCC. We got new methods. We reanalyze this, and the costs at startup are almost the same. And long term, you still got the massive durability benefits with concrete.
Yeah, no, 100%. And that's what drew me to this article. And I'm going to read verbatim. Don't like to do this all the time, but basically they come out in the article and say, just start moving your paving projects to concrete. But they say verbatim, yet another way is to switch from asphalt pavement surfaces to concrete, which has a higher initial cost but is more durable, as you said, leading to equal or lower total life cycle costs. And then they go on to say many road surfaces in the northern U.S. states already use concrete, but asphalt is more prevalent in the south. There it makes even more of a difference because the asphalt is especially subject to deflection in hot weather. And they even went on to say just upgrading the road surfaces in Texas alone could make a significant impact because of the state's large network of roads and how hot it gets. And not that state alone, but you take that all the way to Southern California, all the way east, or through Alabama and Florida. You look at road temperatures that are constantly 120, 130 degrees during the day, and how much deflection that they probably endure because that asphalt is just so soft.
Yeah, well, growing up, the first time I learned about that was there were some gnarly intersections where I grew up in Birmingham, Alabama. They were just rocky, rutted out.
Shaped like a W.
Yeah. And your car's just boom, 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 pulling up to the stoplight. Like, what in the world is this? Heavy tractor trailers are pulling up and they're hitting their brakes. And because it's so hot on that asphalt surface, it's actually molding it and rolling it and grooving it. And they have to come and redo these intersections. So what states started doing is they started pouring concrete just in the intersection. So it would look like a concrete plus sign at this four-way stop, and then everything else was asphalt, because they know that the concrete is that much more durable because of the harder surface, but the asphalt is that much cheaper when you're looking at these short-term budget items, which is how the cities and the states, unfortunately, are looking at it.
Yeah, you can tell a difference, too, when you're standing on it. I remember at the old job when we'd be paving, and if I stood around on a concrete slab all day, my knees would kill me. And you could literally tell a difference from when you stepped off of a concrete slab onto some asphalt. There was just more, there wasn't much, but there was just enough cushion there that you could just feel the energy leaving your foot and going through the asphalt because it was so much softer.
Part of that climate benefit you were looking at, was it talking about the heat that's generated off of a light surface versus a dark surface?
No, that's an interesting point, but it didn't say anything about building heat in one source more so than the other.
Yeah, I wasn't sure. I mean, we hear a lot of talk in these city projects where they're, white coating the roofs. So they're turning these black tar roofs into white roofs. And so I wonder if there's a difference between a gray concrete and a black tar asphalt.
Yeah, it's interesting. Yeah, you can get deep into the weeds on that stuff too, because then you have to compare the carbon emissions from concrete paving versus the asphalt paving.
Well, I don't know if they are, but they're probably close to the same.
I remember hearing about white topping back in college. And I remember there was a pretty lengthy discussion about white topping and how they put it on the tops of buildings in these big metro areas just because of the heat reflection coming off the top instead of, the black tar or whatever on top of buildings.
Yeah, that still goes on now. They get LEED credits for now.
Mm-hmm.
If you build your building, make sure you got that. And they put these gardens and stuff on top that helps cool everything off and pull in that carbon dioxide into the plants, release it into oxygen. So they're trying all kinds of stuff. I was just curious if this study from MIT, which is talking about reducing carbon emissions over the long term and then also improving the durability of the roads at the same time, it was also taking into account the heat that's generated off these asphalt roads compared to what would be generated off of a concrete road.
Yeah, that's an interesting viewpoint for sure.
You were talking about your article there, Josh, about sustainability and kind of the green side of things for concrete. And that leads us into what I found out that was pretty interesting in this article here. It has to do with sustainability in concrete that's used for coastlines. And we all know if you just dump concrete in the ocean, it's not really good for anything. And they kind of go into, not to go into very much detail in this long article, but they essentially said there's things we can do to or with concrete for these coastlines that would benefit or not have an effect on marine biology in the area. An example they had was there's a bridge in Hong Kong, and I didn't even try to write it down or pronounce the name. So we'll just say it's a big, long, 34-mile long bridge in Hong Kong with a name that I cannot pronounce. And so this bridge used over 1 million tons of concrete. And it used so much concrete and there was so much stuff going in the water during the construction of this bridge that there was a subspecies of dolphin, like the flipper kind of dolphin, not the fish dolphin. It decreased the population of this dolphin around the bridge 60%. So in that region where they built that bridge, there were dead dolphins just like washing up on the shoreline. And so it kind of got them thinking about what concrete is doing to the water that they're putting it in. And it got people to thinking about how much coastline in the world is made up of concrete, and not necessarily like a concrete beach, but just where there's development and there's seawalls and there's all kinds of stuff going on right by the ocean. And they talk about how China, 60% of its coast is concrete. 40% of it is like non-concrete. I don't know. It was amazing to me. Just thinking about how much development's going on in that country. And then in the U.S. alone, we got 14,000 miles of concrete coastline. And so,
but that also takes into account like shipping ports and stuff like
harbors,
that. Yeah, harbors, ports.
Yeah. I would say that it's either concrete or it's a natural shoreline. I mean, I would go so far as to say that because I couldn't think of any other material or any other situation where there would be something else there that's not concrete or natural shoreline.
14,000 miles long.
Oh, for sure.
Yeah, that's a lot. And so they also go into how much, concrete is used all over the world and how much of an effect that it's having on the environment. It's the most widely used product in the world, building product in the world. For every person in the world, this said this in the article, for every person in the world, there's 3 tons of concrete being used every year. And 8% of humanity's carbon footprint comes from the concrete industry. And I don't know if I guess they're including, cement production, anything to do with aggregates, admixtures, and whatever else. So I don't know. That was pretty interesting. So what they're thinking about doing is there's a company out there, and I didn't get the name of the company, but they make a product called They call it e-concrete, ECO, all caps and NCRETE. And what it does, it produces bioenhancing concrete products that's intended to protect and rejuvenate coastlines. What consists of this e-concrete? It's made with pretty much 100% byproducts or recycled materials. For their cementitious, they don't use cement. They use the 70% of this mix consists of slag, which those of us in the industry know is a byproduct of metal and things like that. And they use this because it has such a high chloride resistance, which is really good for seawater. And on top of all that, they're going to add what they call eco tiles to the surface of this concrete. When I was reading the article, it really made sense. When you just pour like a smooth concrete slab, it's just that. It's just a smooth slab, and for marine organisms, it's kind of hard for them to latch onto that. So when you just sink a piece of concrete that's smooth on all sides, you don't really have as many barnacles or the little, any other little organisms under the water that can latch onto that. And it made sense too, because even here with habitat management, just on land, if you have just a smooth mowed field or field of grass, it's not really going to benefit anything. You need shrubs and you need trees and you need a whole mixture of things going on that piece of earth for anything to benefit from it. And it's the same thing underwater. So what they do with these eco tiles, they put these eco tiles on the surface of the concrete, and it creates quote unquote more habitat, a more sustainable environment for marine organisms. So it has ridges and it's got grooves and pockets and things like that. So on the existing concrete that's underwater, they can just stick these things on there, and it provides habitat for all this stuff. So that's kind of what they're getting at. And they're also creating, and Paul and Josh, you guys remember when I think it was in Australia, they had those big jack-looking products made out of concrete on the shoreline. Acropodes. And those would be used for, I guess, erosion.
They're seawater breaks. So if you're building a new port that hadn't been done before, you set those, and that's the barrier between the earth or the ground that you're going to be working on and the seawater itself. So it's the break between that.
Yeah, so they're using things like that and just similar products for these concrete coastlines, and those essentially serve as shelter for crabs and shellfish and small bait fish, and it creates habitat around these places.
Yeah, it's like an artificial reef. They're going out and they're building artificial reefs with concrete surfaces. That's awesome. Yeah, I think Joe said 8% is what concrete industry delivers as far as CO2 emissions. So 8% of all the emissions because of concrete. But like 5% of that is the cement.
Right.
So then the aggregates play a part and the concrete plays a part. But 5% of that is cement. And so it goes back to episode 1 when we talked with Ryan Betts about Portland limestone cement. You can cut that 5%, you can cut that by 10%. You start getting closer. And so if you cut that 5% by 10%, so you get a 0.5% gain, that's the entire gain you're talking about in that MIT study.
Right.
Just by switching to the Portland limestone cement. So, I think these things are going to gain traction. The things you talked about, Josh, Portland limestone cement. And it's really cool to hear that somebody's taking it underwater and restoring some of these ocean habitats and making them better through concrete.
Yeah, and the thing about coastlines too, there's only so many. There's only so many miles of coastline versus, just look at America. You got only so many miles on the West Coast, so many miles on the East and Gulf Coast, and that's not a whole lot. And if something happens to all of that, then those habitats and those areas are going to be devoid of certain species for however long, decades, if not forever.
Yeah, well, good stuff, guys. I really enjoy this section of the show where we get to talk shop and talk about the things that we see just passing through, scrolling the internet, talking to other people within the industry. These kind of topics are certainly interesting to me. Hopefully they are to our audience as well. But transitioning to the next section here, we're going to bring in our guest. Our guest is Jim Casilio today. He is the Director of Technical Services for the Pennsylvania Aggregates and Concrete Association. And we're going to jump right into the conversation here. Paul is going to be conducting the interview with Jim directly. Joey and I will chime in from time to time. But the conversation is a good one. Jim has a lot of experience, as we talked about earlier in the show. We kind of touched on who Jim is and what he does. And we're going to get into all types of different conversation topics, things that are very interesting. And Jim's a great guy. He's a great guest. And he can take a conversation and just roll with it. And the amount of information you can learn from Jim just by listening is pretty incredible. So without further ado, this is our guest for episode 3 of the Add 10 Gallons Concrete Podcast, is Jim Casilio.
We're ready to talk about the building code legislation. We're exciting. It's the same, addressing the same thing on a much one step lower level. You know, the legislation is going to require them to provide the curing box and require them to do automated curing and make it available to us without hands-on. So, and I don't have to trace across 2 states to break cores then what they were doing the testing, right? Like I just had to do the past 2 days.
Right. Well, let's jump right into that. So you're talking about making it mandatory for these people to be ACI grade 1, C39 strength test certified. Are these testing labs not doing that already with their field testers?
If you read the code, and by the building code, I mean ACI 318 version 14, which is Pennsylvania on. So if we adopt that, we'll only be 6 years behind the ACI code. But don't get me started. That's a whole nother podcast. It says, if you read that the technicians making the tests must be certified acceptable to the building code official and licensed design professional. And then right next to the code is a commentary. They say ACI grade 1 field technician or equivalent. All right. Now, that or equivalent is the testing labs say, well, we have our own training program that's equivalent, that's horse crap. You know, they just don't. But they say that they do and they get away with it. So the people out there doing the job properly with the trained guys are losing out, because it's a low bid kind of market, losing out to the guys who are coming in and doing this here. And then you get stuck like we just got done here now, cylinders that do not represent the in-place strength of the concrete. The producers is guilty and proven innocent, and even if he proved himself innocent, they still have our money. So good luck trying to get that. You know, well, if didn't delay them an hour, they'll say, oh, we're going to back charge you for that. Well, all the extra testing. Well, you know, so it is a bit of a loophole. What this amendment does is bring it right on the forefront. Says to Mr. Building Official and Licensed Design Professional, minimum requirements. If your inspectors and technicians have this certification, they're good to go. All right, so it brings it right out and gets kind of rid of the ambiguous language and puts it in the forefront, so there's no ifs, ands, or buts. You know, got to make it simple, got to make it easy to find, and it's not in the code right now.
Right. Well, when it comes to like strength testing, not to be too overly negative or anything, but you could train a monkey to break a cylinder. But you went through something that was a little bit different this week. Could you tell the team here and the people listening the experience you had with these cores? Sure.
So what we have is a testing agency hired to do a project in, let's say, northeastern Pennsylvania, about an hour and away from north of Harrisburg, a parking garage being built. And so it was very warm here in July and August, and initially their cylinder curing was get a cooler out there and put the cylinders in and close the lid up and come back the next day and take it out. And well, once producers started getting brakes back, and in end July, he kind of, called them on that. And in the meantime, then they put water in it, then they put high lows in it. And so the brakes have been better. But you have concrete board from late June up until July. Now it's coming to 28-day brakes come, and you got great 7-day results, but you almost no strength gain 7 to 28 days. Say you're getting 3,400, 3,500 in 7 days, 3,800, 3,900 in 28 days. It's a classic case of the concrete being burned out. Now, this is 4,000 and 5,000 mix specified with straight cement, no pozzolans on it, 7% air, big walls, big columns. All right, so they're generating enough heat on their own besides being warm. A great mix for October and September, but late September, October, November, but July, not so good.
Yeah,
so Yeah, so they're low. All right. So now there's coring. So last week there were 15 or so cores pulled, 9 of them to be tested by the testing lab, and the producer's cement supplier took 4 on his own to break them and do petrography, be done as companion cores. So we go down to break the cores at the lab yesterday, and the cores are all there, and to get ready, they're going to start cut them off like that. And I says, how are we going to cap the cores? And he says, we're going to use neoprene pads. I says, well, that's great. Well, the rule in C42, ASTM C42 for the cores is that the steel rings and the retainer rings can be no greater than 1.07% times the diameter of the core. This is a 4-inch core, but it's a 4-inch OD diameter. So the core is like just under 3 3/4 ID. Very common, because core drillers, worry about the outside of the hole. I could drill a 4-inch hole, you got a 4-inch OD on it.
Yeah.
Right? So what we found out, those retaining rings weren't ready to go. Now, if we hadn't been there and called that question, those cores would have got broken or tested according to that, and the results were, maybe not so good. So we talked to lab, and the guys did a good job, and they said, hey, our lab, an hour and a half away from us, has the ability to cap the cores. We went down there, we got the cores capped today. They did it right, just as you expect to see. The plate was warm, the sulfur capping compound was good. The young man was doing that, not his first time sulfur capping compound, nice thin cores. As soon as he brought the cores out, he checked for perpendicularity, had the right type of gauge right there. He was doing the right thing, so felt really good about that capping. We came back and broke them this afternoon, and we're all in good shape. So the cores broke way higher than the cylinders. Again, a good day for the producer. He's relieved because he was sweating out. The job was shut down, based on because they don't want to put further stuff on top of stuff they might have to take out. And so here it is. But the problem was they were just going to go and just do it without any watching whether they're meeting the tolerance on the cores. And that could have been very costly for my producer, on top of the pain he's already suffering from having low cylinder breaks that really are not a true measure of his concrete.
So how long is it until we get to a point where we take all those variables out of it? We take out the variables of making the cylinders, storing them properly, curing them properly, and then breaking them properly. Well, in this case, you're breaking cores, not cylinders, but still the same concept, all these variables. And when are we going to move from that to link technology to this job? So you get embedded probes that are going to, be able to use the maturity method and send the information to an app. And that gets, there's a repository for the state that everybody can access.
Well, I don't think maturity is going to replace it anytime soon, because of the specifics of marrying maturity to actual breaks. Now, maturity is wonderful for a large job site if you know when you can move ahead, but acceptance on maturity, probably not going to see that commonplace too soon. But there is technology we can use to eliminate some of that, and the legislation we had talked about is going to require it. You saw the demonstration, Paul, that we did with that device from Geotech, that everybody in that room could read what happened on that pretend curing box we made up for the previous 48 hours. And the probe costs $95 and has 2 years of battery life, and the software is free. Now, they're just one of many manufacturers who are making these devices that are available, and so what we're talking about, everybody should have it, and that's the hands-free monitoring, that no one has to put a min-max thermometer in and read a min-max thermometer. This thing takes the readings all the time, and there's the data available for everybody to see. That would be a huge step on that, because it's purely monitoring initial conditions. The first 24 hours life of a cylinder are so much more important than the rest of the 27 days on it, and proven time and time again, and here we went through it again.
Well, you're giving that talk in this demonstration to the concrete guys and aggregate guys and the cement guys that were in that room, but to me, the way this change gets made is actually through the testing companies. They should be adopting this and promoting this to solidify the results and move this industry forward. Do you agree?
They're going to be the ultimate users of it, and they're going, and it's going to be a combination of them wanting to do the right thing and bring pressure from the industry, establishing the standard. The bar is here. We got to just raise that bar a little bit and inspect that. Well, let's say who's losing in this situation. In the situation we have here now, the concrete contractor, he doesn't know whether he can build on top of it. The CM, he's got a mess on his hands. The architect and licensed design professional, they're sitting there, well, what numbers do we believe? The owner's paying for all this, and at the bottom of the run, the concrete supplier is sweating bullets, and the poor guy can't sleep that night. The only person that's benefiting in this process is a testing agency that's low bidding it, and hey, whatever, we're doing it. We don't have to do it. Also, the loser in this too are the testing agencies that are doing it the right way, coming up with the automated curing boxes, doing the right thing. They're the losers in this process here. We've got to support them and put pressure on this industry to raise the bar across the industry through the professionals, through the contractors, through the suppliers, through the concrete contractors. Everybody's got to get on board and say, we're just not going to accept this anymore. The problems happen in the summer and the problems happen in the winter in our neck of the woods. Other areas of the country, different problem, but everybody's going through this. This is a nationwide issue, and it's unfortunately going from bad to worse. It just is, and I've seen that over my career.
Well, with the business side of it that we're in, with the product that we're always using, we're a disruptive technology. So when I see other disruptive technologies, that's right where my mind goes is who's the winner and who's the loser. And you outline kind of who's being harmed right now with the current system, and how we can lift those standards, and a rising tide can lift all boats in this situation. But I looked at that probe that you showed us in the app and Ironbank Access, and I'm thinking that's a disruptive technology to these testing labs, because right now all these projects are beholden to the labs. The labs are taking the cylinders, the labs are curing everything, the labs are giving you numbers, and as Jim just said, everybody's waiting. You're waiting on those numbers. But if everybody has access to the numbers through this technology, then that won't be the case. So if I'm a testing lab, I would see this disruptive technology, and I would be on it like white on rice. And I would be spending the next year right now doing companion tests. And so I'd be doing all the normal stuff while I have the probes in there. And I'd be getting these correlations and make sure this stuff checking out. And then when I'm confident in that, we start writing ASTMs for it, saying, oh, here's the procedures, exactly where we need to place these things. These are the conditions. These are the products you can use, and define those things. And that's a 4-year process if you're lucky. So then 5 years from now, you're the testing lab that's ahead of the game. You've got a better technology. You wrote the specs, and potentially you're saying it's a low bid thing, but when you're that much better and that much more connected, I think you could maybe charge a premium.
And the testing labs, there are a segment of the market where there are CMs and repeat owners who are working with certain testing agencies because they are doing the right thing. They're going that extra. They're not losing any time and effort. They know they can count on their numbers. But yet again, there's still enough critical mass out there that unfortunately they're the exception to the rule. But those are the guys we need to support. And there's a few of them who are like your company, Paul, who are members of the association, who are all for that and all behind this. So this is a process.
Speaking of the association, take a moment and tell the people who it is you're working for and what your role is.
Sure. The association that we talked about is the Pennsylvania Aggregate and Concrete Association. Director of Technical Services for that. We represent the aggregate and concrete producers and cement producers of Pennsylvania. There's 5 of us here on staff. My counterpart who does regulatory affairs is Josie Gasky. I spend a lot of quality time with the Department of Transportation. She spends a lot of quality time with the Department of Environmental Resources. Our cement producers and our quarries are extremely closely regulated by Department of Environmental Protection. All the permits come from them, and so it matters what the rules are the DEP has on that. It matters to our producers greatly. And we also have Ken Crank, who's our Director of Promotion, Concrete Promotion, and also working with me on the building codes. He's also in charge of our certification program. Ken runs all of our certification programs. We're probably 500 to 700 people a year that we run through our ACI concrete field testing, concrete flat work finisher, concrete strength testing program. And also now we started, and we want to talk about the NRMCA exterior flat work finisher program. We're the third state to bring that to the local level, and that's a different tenure in that program, and it's something that I think valuable for all the producers and everybody in the industry out there. And then besides that, Callie Klein is our director of events and education. She's been with the association for quite some time, and we're all led by Peter Vlahos. Peter came from work with NRMCA and the ConAg ConExpo, and he's been here as our president in Pennsylvania here for about 12 years now. Offices in Harrisburg. Ken and I work out of our homes remotely, and then in March, the rest of the world joined us working from home. I wish you guys would all go back to work at the office and leave us people at home back to peace and quiet. But, I don't think that's happening anytime soon. So, hey, it's not bad working at home until your significant other has to work at home, too. Then it's a whole other ballgame on that respect.
People with kids.
Yeah, you guys with people with young kids, I feel for you during this time. I absolutely do. So that's the five of us, and it's my privilege to represent the producers after being one for most of my career. Most of my career spent in the family concrete business. Frank Casilio and Sons in Bethlehem, Pennsylvania. Started my grandfather in 1938. My sister and my nephew currently run the business with a lot of good long-term employees, and business is busy. And Allentown in Bethlehem, Pennsylvania, we call it the Lehigh Valley area, which we can talk about too, was the birthplace of the cement industry in the United States. The first cement kilns in the United States were built in the Lehigh Valley, and we still have 4 mills in operation there in the Lehigh Valley now. So registered professional engineer, University of Pittsburgh graduate many, many moons ago. But most of my life in the concrete business, and a little stint doing some geotechnical engineering and foundation testing.
Thank you for all that background. That was phenomenal. You mentioned a lot of things you wanted to talk about there, but let's start with this. You mentioned COVID has really changed things, and my appreciation for your organization really, I can't adequately say how impressed I was with the documents that were coming out, because it was a time where nobody really knew what was going on, or where do we go, who can be where, what safety gear do we need, Governor Wolf in Pennsylvania saying we have to have these massive plans and these safety ambassadors, like we need what? And so it was very murky, and PACA came out immediately. It couldn't have been 7 days since Governor Wolf even announced that you needed all this paperwork. And you guys came out with a template and said, all you got to do is fill in your name on this, how many employees you have, and your address, and you're good to go, and you're in compliance. It was phenomenal. And you said a member of the association actually put that together.
Yeah. Like all good associations, our strength is in our members, and our members are active and engaged. And so what happened on that, when we finally got the back to work release on a Friday afternoon, they said, here is the form that you need to fill out. And it wasn't as easy as cut and dry like that. So one of my members took it on itself, and I worked with him, and we said, we got to get a template out to all of our producers. So because we have 70 some members, and these guys you'd have 70 some different versions of this form out there. They had to submit that form to their local PennDOT office to get approved to stay open. So you can imagine it would then get reviewed by 11 different PennDOT districts. So you would have 70 versions reviewed by 11 different guys. Do the math, that would not be a pretty number of variations that's out there. So we tried to standardize it as quick as we could by saying, here's a plan. Does this sound good? Fill in the details specific to your organization. And most concrete plants, most quarries are pretty similar. You just got to say exactly what is where and everything like that. And we were able to get our guys back up and running as quickly as possible and safely as possible with very little blowback, if you want to put it, or stumbles along the way. A couple of people said, well, we don't like this and we don't like that, but there was no real major issues on that. After starting, it was kind of, you mentioned the government administration, and we had a really tough time following the rules that were coming out here. So what we ended up doing was initially the rules were that the concrete industry was ruled essential and could stay open. Their contractors weren't, so we were allowed to, our concrete companies were allowed to be open. We weren't allowed to have customers.
Yep, I remember that. Yep.
Then the second thing was, well, the quarries weren't allowed to be open. Well, wait a minute, how are we going to make concrete if the quarries aren't allowed to be open? So we're able to very quickly get to the governor's office and get clarification and show them, guys, might be a mistake. You might want to reconsider that. And they did. And so fortunately, our quarries were able to open up just as quickly as our concrete plants were. Cement plants are, again, staying open all the time like that. Realize you don't just turn a cement plant off. You just don't do that.
Well, I give Governor Wolf a little bit of credit here. This always came out with a big old list that said what is or isn't a non-essential business. The problem is there were so many things that are essential that were considered non-essential, and it disrupted so much stuff. And everything, construction was halted for like 7 full days. We were like one of only 2 states in Pennsylvania that actually stopped construction.
Yes, that would create an outrage and a lot of confusion. But then again, it was about within a month later, we started back up slowly but surely. And now everyone's very busy. Trying to play a little bit of catch up. We're not going to get those days back. I mean, we're just not. But everybody's out there working as hard as we can and to make it as decent a year as we can.
Yeah, absolutely. Well, you got things turned around very quickly. How do you? What are the channels? Like, how are you working to get things done? Those messages to the highest office in the state, and how does that work?
Since we were able to bring our industry to many tables that we've never had that before, and that's through the work of the association. Since Peter came to Pennsylvania and revamped our association 12 years ago, we'll be able to talk to the Department of PennDOT at the highest level as well as to DEP. And also forgot to mention that we have a lobbyist who's really our 5th staff member like that, who does a great job for us on that. And we were just able to attack it from above and below. We were able to talk to the governor's office, the legislator, and also to the agencies that we work with, Department of Transportation, Department of Environmental Resources, get the message going from the top and the bottom, kind of meet in the middle and get a consensus on it. So it certainly wasn't one conversation, it was a lot of conversations.
Yeah,
that needed to happen.
Another thing that I want to credit the organization with, I went to the in-person meeting back in March, the last one that we had before COVID. Yeah. Shut everything down, moved everything online. And in it, you said in the agenda, you're like, hey, the DOT's going to be there, and he's going to be there to talk about some of these projects and some of the things that are going wrong. So everybody be prepared with whatever you want to say. And just my experience in the concrete industry and working with government officials, I expected this to be a total session where everybody's whining, complaining, and pointing fingers and mad about everything. And I went in and I was expecting that. And although there were some gruff people, it was very productive. The respect between the industries, the respect between the producers, and even the respect they showed to that guy from the DOT, things went much more smoothly. And I got to say that's got to be a credit to Peter and him coming in and changing the culture in your organization.
Right. The important thing is what I have tried to do in agreement with our leadership is that the Department of Transportation, they're our customer, and if we treat them as a customer, and they may not always be right, but they're always the customer now, but they're also us. They manage the assets for all of us, and the transportation system is an important asset, and there's never enough dollars out there to go fix what needs to be fixed, and they're doing the best they can for us. So if we've got good ideas, we've got good things that we think will help that benefit everybody, it benefits us, we'll try, and that's the approach we made. We're then trying to be the squeaky wheel. We try to come with solutions on that and have a constructive dialogue. And that starts from the top down. They've got some leadership at the top of the Department of Transportation that said that's an important focus to them. Now, it's a tough job. It's a 10,000-man organization. You don't move that dinosaur, shift the culture of that really quickly. But yet again, they've been open to that. And and it's been productive. And so we want to maintain the dialogue. And this is not my quote, but it's from the Deputy Secretary now, Executive Deputy Secretary, is we're not always going to agree, but we have to have a relationship, and a relationship that's strong enough to tolerate some disagreements, but yet to be able to work together productively. So hopefully that's what you saw, and I'm glad that you verified that's what you saw. It's what we're trying to do. Because then,
it is what I saw.
Producers have a seat at the table then. The producers then could speak with the highest people in the department then, and that is our job as the association, is to keep that seat at the table open for them. And then we'll work on the details once we get there.
And you said that part of having a better culture inside of PACA, inside of the state organizations, and then now you're extending that into the producers, and part of that beefing up the culture is in the certification and testing side and performance side. And one of the things you mentioned is Pennsylvania is only the third state to adopt a training program for flatwork finishers. Can you go into that for me?
Sure. Again, it was necessity, the mother of invention. We had a rash of scaling in northeastern Pennsylvania a couple winters ago, and that was when we were on our old ASR specification, and when a producer lost his fly ash source and had to go to a large amount of slag cement, and finishers weren't used to doing that. So we have, a few thousand yards covered over about half a dozen companies, maybe 12 projects or so, where we had a lot of scaling. And this is concrete that were high profile, and so everybody ended up with a lot of egg on the face. By that spring, we had a solution, but now the contractors were there. Oh, what do we do about all this bad concrete out there? Municipalities have it down. This is on public work. It was on private work. It was on PennDOT jobs. It was jobs done to the PennDOT specification. It was pretty widespread. So during one of these meetings, Henry Prenninger with Lafarge, who's out of the Baltimore area, came up and attended one of the meetings and says, we developed a program working with Delaware and Maryland where we certify the flatwork finishers. Now, opposed to being an ACI certified concrete finisher, that's a pretty intense program. It's mostly geared towards buildings. This is a much more limited in scope and completely or strictly addresses the limitations and what you need to do to finish exterior concrete, make it durable to freezing and thawing conditions, and reduce the scaling. It is a written test and a performance test, but it is a written test that every finisher should be able to pass. But unlike the ACI program, it has a performance test, and the performance test is we set up little blocks for them to pour, and then after we do the written test in the morning, we break them up in groups of 3 or 4, and we back up a concrete truck, and there's a 13-step checklist for them to place and finish it. Now, we're not really that concerned about the 13 steps and the guys paying attention in the morning, they'll all get them, but it is an education opportunity. It's education for them to discuss. It's also an opportunity for them to work with finishers from other companies. We ask a lot of our finishers, but we give them very little in training. Their training of a concrete finisher most is the guy next to you yelling at you, and how well he yells at you is the quality of training that you get. But yet it exposes our vulnerability. As a ready mix producer, you do not produce a finished product. It is up for your customer to make it into a finished product, just like the testing agency is up for them to test it right. That is our vulnerability. Our material looks as good as they make it look good, and we ask a lot. So this course we're very excited about, because all of us in the concrete industry have been out on residential projects where you have a disappointed homeowner and a disappointed owner, and you're stuck in the middle between the owner and your customer on the other side. The finishing and the curing, which was our problem up in Northeast Pennsylvania, both finishing and curing was needed where it should be, and then you got to make these two meet in the middle while still retaining the customer and trying to help the homeowner out because it didn't meet their expectations. And there's nothing worse than that, and somebody just spent all that money and it didn't meet their expectation. The whole industry gets this. And one of the quotes we use in this program is it's not an industry, it's not a concrete producer problem, it's not a finisher problem, it's not a specifier problem, it's an industry problem. And we better work on this and solve this together or we're all going to end up with more bad situations that none of us want. So it's the NRMCA finisher. Nice thing about it, it's a lifetime certification. So as long as you really don't screw things up badly, you go through the course once, you're certified for life. And we think it's a way of addressing not only our specific problem we had, but also for improving equality. So the rules going to be put in place are going to require all finishers on PennDOT projects to have this or the ACI certification by the end of 2021. So that's a lot of finishers that we're going to put through this process. And we also developed a training module for construction inspectors to know intermediate curing and the importance of final curing and everything like that, because the big key on this is, and especially with the SCMs, is curing. So we hit that really hard in the program.
Well, it's interesting. The name of this podcast is born out of the same phenomenon. It's the Add 10 Gallons Concrete Podcast, because we noticed in this industry, no matter how much time, effort, money that we put into concrete technology, or that the additive company puts into concrete technology, or how much mixed design knowledge the concrete producer put into it, when that truck shows up, the dude flashes his hands and he has 10 gallons of water, all that money and knowledge it's gone. It's wasted. It's over.
I love the title of the podcast. I have been instructed to do that, and my role as a ready mix concrete producer, even before I pull the truck in, I've had that flashed at me numerous times.
Exactly.
All right, so that's why I love that. Everybody, and if you haven't seen that, you haven't driven a mixer truck long enough, because that is, everybody knows that, and I love the title of the podcast on that. But that brings me something I wanted to say and follow up on something from your first podcast when you talked about the industry slow to accept change and the conservative nature of the industry. And that, I'm going to say, that's maybe a yes and a no comment on that. But there is a bit of a reason for that, and we all have a story or two to tell that gets us on that. And I've got a couple. And the first one is called a product called Pyramid, and the second one is about slag cement. Now, Pyramid was a product produced and marketed by one of the cement companies that is no longer in existence, got absorbed by another cement company. But its claim to fame was rapid setting, high strength. And their advertisement, very flashy advertisement, was done with the plane could take off from Los Angeles, and you could pour the concrete when the plane takes off, and it can land on in New York City 3 hours later. That's how strong we gain our strength. So they marketed it heavy. And we say, okay, we'll give it a try. Well, we poured a little bit on our driveway at a ready-mix concrete plant, so I always like to be conservative and try a little bit. That was a bugger to work with, and sure enough, it set quick, and sure enough, its strength good, but it also did something else. Within about 4 or 5 months, you have never seen this much cracking anywhere on it. I mean, it just cracked a tremendous amount to the point that it ended up being replaced in a couple years. In the meantime, this was out and widely knowledge within the industry, but this was promoted by a large company, with a lot of good science technically behind it, and done with a huge marketing campaign. And so, trust me, and this is many, many years ago. I remember that, so I doubt remember. So when anybody comes, this is our reluctance, a new product, everybody has a story like that. And the second one is the widespread use of slag cement. Now, that was available in the 70s, but not that widely used. In our area in Pennsylvania, when the cement company started manufacturing and marketed, and that's when it really got widely used, late 80s, early 90s. And that got adapted very quickly into the marketplace. I had the opportunity to start using it and decided to use it at a replacement rate I thought was conservative, that would give me some benefits on like that. And it did. I was very pleased with how it worked. It improved my concrete. But there was also a temptation back then, because this was a grade 120 slag, widely available, cost was good, that you could really, if you wanted to, drop your total cementitious of your mixes and still be well within the strength that you needed. Now, if you upped your percentage of replacements, you could even drop your total cementitious even more. I decided not to do that. Some of my competition did not. And within a year or two, they had a lot of scaling on a lot of commercial jobs, because the finishers weren't used to finish it. Because when you get high percentages of slag, it finishes differently. The finishability window, it gets extended, it moves out a little bit here like that. And when you think it's time to go, it may not be time to go. Top's more susceptible to dry out before the bottom sets. You're more easy to jump the slab, and it's more susceptible to curing. Now, we know that was the issue, but what happened was construction managers, one in particular, took slag cement, and he made that his personal mission in life, to go around to all the specifiers that he knew, and he got that omitted from specifications. Now, that seems crazy in this day and age that people would not do that, but he did, because he was blaming the material because it was a misapplication of the material. A good product that or the right application and the right percentage became a bad product in other people's hands and got a bad name. So there you have two stories of why you may think that the industry being slow to change and these things happen. And there's also one of the best parts about our industry is, and I'm going to use the expression, we are inbred elephants. And I mean that in the most complimentary way I can say.
Please explain.
Because it's a small industry. We all share customers, we all share vendors, we all share suppliers. We have some kind of relationship with each other, hence the inbred. And with the pyramid story and the slag cement story, is obvious we forget nothing. So, these things, they last a generation and they die a slow death. So hence the term inbred elephants. But the nice part about that is, if you're the type of person selling the product in the right way, standing behind the right product, working with a producer, working within the industry, you'll build that level of respect and credibility that they'll remember you, and your one success builds to another like that. This industry is full of people who are very credible, who work credible, because if you don't, you won't survive in this industry. Just like the pyramid guys, the guys that did that end up with some serious egg in the face. Well, of course their credibility is shot in that respect. So, that's why this industry, we're all in it because we like to build stuff. That's the cool thing about what we do. We like to make stuff, we like to build stuff, but as the time goes on, you realize that there's a lot of good, honest, hardworking people in the industry, the kind of people you enjoy doing business with. And that's why, I had the opportunity, and I think it's my privilege to stay in the industry and represent the industry at the level that I do. So I'm that's at least what I found over my few years of doing this.
That's interesting about the pyramid story. I heard a similar story, and again, I got this third hand because in my previous employer, I worked for Lafarge before I came here. And when I was there, I was out of academia and been in the lab for a couple of years, and I didn't see anything wrong with using metakaolin. I was like, why aren't more people using this? Like, this seems to solve problems. It actually makes concrete a little bit better, the fresh properties, the hardened properties, and it's solving some problems. So I didn't understand. It's like, why aren't we using this? Why isn't this commonplace? And I got an interesting story back, similar to your pyramid story. They said, well, we did jump on this in the 80s when it came out. It was hot stuff, and everybody wanted it. Everybody was using it. It was really great. Then all of a sudden, you would get loads of this stuff in, and it didn't work at all. It was just nothing, non-reactive. Mm-hmm. And so your brakes were horrible. You're getting your ASR problems, whatever it is that you were using it for the benefit. It just wasn't happening. And what they found out was the people who were taking the kaolin and making it metakaolin through heating it up, through calcining it, they were cooking it too long. And they were taking it out of the meta phase and completely calcining it and burning it. And it was non-reactive. Oh. And that process of keeping it between, or like right around the 800, 900 degrees Celsius, so that it's that meta phase, that metakaolin, it was very difficult. And when you end up with all the burned product, and they end up burning their customers, and people just dropped it.
Yeah, just dropped it, and tough. Good luck getting that business back once that happens.
Yeah, it's gone. And there's a lot of people now that are looking at that thinking, hey, I can make that. And it's like, whoa, it's going to be twice the price of cement per ton. So you're really going to have to sell this thing. And by the way, everybody that's still around from the 80s had a bad taste in their mouth. Good luck. There's another technology coming out right now that it's in the research. And I I don't know how quickly it's going to come to market, but we're very interested here, and that's 3D printed concrete. Do you ever finger on that at all? Are you looking at that at all? What do you think about it?
I think that's going to be something you're going to see on the precast and the concrete product side before it gets over to the industry that I'm more familiar with. It is probably going to make strong inroads there first and foremost. They're the guys that also are going to be on the fancy carbon replacements, the new technologies, the alternate cements, because they can control that in the process. Again, we don't make a finished product. It's so important about what's going to happen out there, on the job site. But I think they're going to be the first people to adopt those kind of things. And I think you're going to see that a whole lot sooner than later.
You think the 3D printed concrete's going to come to market sooner, like within 10 years?
Oh, yeah. You'll see that. But you'll see that first on the precast concrete product side, where they have total control over the manufactured product. When you buy it from them, you're buying a finished product. For us, it's a raw material thing.
See, because when I think about the 3D printed side, I actually think they're trying to take the precast mindset and move it outside. So in my mind, I don't see the precast guys buying these robots and 3D printing in their little warehouses and putting on trucks. I see them taking that mindset into the field, and they're going to print these small houses or shelters or walls or whatever it is they're going to start with. They're going to cast it in place. And so that's where I wonder whether all these mixes are going to be pre-bagged mixes and mixed on site, or if it's going to come from ready-mix plants as grout mixes with the right formulations. But I think it's cast in place. Okay,
yeah, you may very well be right. And it's going to be interesting to see. But again, I see sooner or later, in construction, the labor costs are so expensive. It used to be years ago that the labor was one of your least expensive things and your material was the most. I think that's pretty much flipped around completely right now. So if you can not get those costs, that you'll take big advantage. And there is this thing now called the TieBot, and it was developed at Carnegie Mellon, and it's been demoed here in Pennsylvania. You set the steel on a bridge deck, and it automatically comes and ties your steel together overnight. Because that's a brutal job, bend over, putting all those ties in together. They developed this because, CMU, Carnegie Mellon, is one of the leaders in autonomous vehicles. It'll go out, it'll use optics to see where the rebars come together, and it shoots a wire down, and it does all the ties, and it runs on the same rails that the bridge finishing machine will run on. So the steel guys are out there, will set the steel. Still need guys to do that, but they don't have to be bent over all day long tying all those bars together. So, it's out there and it is working.
And that's amazing, because when you were talking about 3D printing, I immediately started thinking about, from my time in the MCAA, talking about these robots that lay brick and block. And I was thinking about that all at the same time. And then Jim comes in here with a Carnegie Mellon, automatic rebar tire or whatever. I think robotics, maybe at the same rate or maybe even a little bit faster, could be adopted, faster than your 3D models would, because, as he alluded to, your benefits there as it relates to your labor costs is just through the roof.
Yeah. You, in our discussion before the interview started, we're doing our current events. Your article that you found was phenomenal, and I'm interested to see if Jim's heard about this research and to see where Pennsylvania is, if we're tracking with this. Could you speak on this article for just a second? And Jim, if you'll hear Josh out for a second, and then sure. I'd love to see what kind of involvement PACA may have, in the direction of concrete roads versus asphalt paving.
Yeah, sure. The principal research scientist, his name is Jeremy Gregory, and he works either with or at MIT. With the help, it's supported through the Concrete Sustainability Hub at MIT with the Portland Cement Association. And basically they came out with a study saying, stiffer roadways could improve truck fuel efficiency. And talking about the benefits of moving to stiffer roadways, whether that be replacing asphalt with concrete or even making concrete roads stiffer through, different gradations and things of that nature.
Adding fibers in or whatever you do.
Right.
Stiffer roads were better and concrete roads would be better than asphalt roads for this. And the benefits to the carbon emissions that they went through, that they looked at, the models that they used, it would be better for the environment. And when Josh was going through the study, it's right in line with the NRMCA is pushing right now. They're really pushing concrete pavement hard. Is that something we do a lot of in the state of Pennsylvania? Are you guys involved with that at all?
That is, to answer your question, that's something that Pennsylvania does not do a lot of its roadways in concrete. We do have a certain percentage of it that is done like that. The larger roadway paving is the association handles that. It's American Concrete Paving Association, which we work closely with, and with their PA chapter on that. And those are the concrete contractors placing that roadway out there. And NRMCA is pushing heavily local streets and roads, because that's more work, more likely for a ready-mix producer that's going to get on that road like that. We've worked hard to get the roller compacted concrete specification into Pennsylvania, and we're finding that having a lot of good applications as a subbase, and then paving asphalt on top of it. So you stumbled upon something, Josh, that is a hot topic that's been a hot topic ever since for the past 40 years, the competition between the two main paving industries. And each state has its own mix and its own complexity as to who does more. What has been proven, if there's a state that has two competitive industries, their overall cost is lower for both of them. Some states are completely asphalt, and their prices are, they're paying for that. Where if you have a competitive industry in some of the states, Wisconsin is a great example for that, their unit cost for both materials is lower because of the competitive nature and the strength of both industries that can provide that on here like that. That's a debate that's been going on, and it's going to continue to go on. So I'm glad to see you guys on it. I mean, it is a hot topic, lifestyle cost analysis and where you put the numbers and what you do on that. Boy, that starts out as a very simple question with a lot of good science behind it. The MIT Sustainability Hub is something that is only maybe 10 years old, co-funded by PCA and NRMCA. They put out a lot of groundbreaking basic research and then give it out to us, the practitioners out in the field, to apply it. They're the science guys behind all this, and it's up to do it. But they've posed a lot of great questions, and to hear Jeremy Gregory speak, he's a very good speaker, and it's a great topic, and more to come on that subject. So yes, we get involved in that, in the competition and trying to promote concrete out there. But we're also the aggregate organization too. So the nice part about that, both materials use aggregate. So we win a little bit on both of them. So
well, there's a third component, and you touched on it at the very beginning of this interview, and that is the money side of it. So what can you tell the layperson? What does the everyman need to know about highway transportation funding on the federal level or on the state level? What should we know? What should we be paying attention to, believing, and looking forward to in that regard?
It's a tough time. The recent virus has exposed the weakness, and the weakness is dependency on gasoline tax, which is most of the states rely on and the federal relies on. Now, spend a few months with nobody driving, every state now has a budget in their a hole in their transportation budget, and it's a big one. And where does that money go from? And that's already against the system, at least in Pennsylvania, because we've got an enormous amount of roadways per capita that we have, that already was at a deficit. There were way more projects out there than money to fix them. And that's just the reality. And there's not a state that's not faced with that reality. And each state approaches it differently, but they also rely on the federal gas tax to come along with it. Now, there has been, and I know we're supposed to not stay political on the podcast, I'll try and go by that, but there's been talk about an infrastructure bill for that to help the states and move this along. There was talk, and now you don't hear any talk about that. But Every state has a deficit. Every state has more projects to do than they have money to do them. And again, like I said before, the bad part is that we don't realize it because we're detached from it. That's something we own. We are all the owners of that. It's not the Department of Transportation that owns that. They just kind of manage that for us and try to do the best they can for us. But that's an asset, and they're not like a regulatory agency. They're an extension of the owner, and that belongs to all of us in every state that we have in here. And we stress our transportation system an enormous amount, and you got to put that money back into it, or it's going to let you down. And you see that in delays, and you see that in construction costs and traffic jams. And we're going to have to be much smarter about managing our roadways, because we can't build ourselves out of this mess. We do not have enough money to add the capacity to do that. So you're going to see a lot in the, like you said, the disruptive technologies, and a lot in the lane switching. They're talking about Philadelphia, talking about soft shoulder running on the Schuylkill Expressway, certain hours of the day where they start run on the shoulders just to add another lane. Now, how that's all going to be done is going to be done with very high-tech monitoring and control, so it's done safely. That's where you're going to see a lot of the increases come in, as they try to manage traffic better on what we have, because unfortunately we don't have enough money or land to build ourselves out of the jam that we've got ourselves into on this. So I wish I had a more optimistic, upbeat subject. You want to talk about something more fun or what?
Well, let's. That leads us in. Okay, something fun. What's the craziest thing that you can remember seeing that you're able to talk about? Well, give us a good story from back in the day.
Good story from back in the day.
Like something crazy you saw on a job. Or...
Something right. And this is not great funny, but it is kind of interesting. 4th of July, a hot 4th of July, and we were busy. It was the Friday before the 4th of July, coming into a 3-day weekend. So a real busy day. It's hot. And so it was middle of the afternoon, and we're finishing up a state job, and the batch man calls me up and says, "Oh, you got to take a look at this load. It's wringing wet." And it was going out to the state, and it really was seeking its own level, kind of. It looked like a drum full of water in a central mix plant. So my God, what's happening? And I turned around on the wall and I looked, and his admixture vial for retarder was completely full. So of admixture. So obviously it got overdosed on retarder. Well, stopped everything down. We threw that load away, went and found that we had just gotten a delivery of retarder. And during the delivery process, the delivery guy somehow hit the wiring on the control mechanism that the admixture pump just started pumping retarder in. So the whole load got nothing but retarder. Now, sent that truck to the reclaimer. Okay, washed the mixer out. Well, we lost a little time, but not the end of the world, yada, yada. So life goes on. We were able to fix the controls back in business in a short period of time. So now that's Friday afternoon. We're not back to work till Tuesday morning. Tuesday morning, a call from a homeowner who we sent a couple yards of concrete to, and said, "Hey, that concrete I got from you on Friday didn't set up." Now, this is Tuesday. And I go, "You got to be kidding me." He says, No, it didn't set up at all. I says, "I'll be right over. I got to see this." And sure enough, I went over, and this guy had built an addition on his house, and we poured a foundation, a little slab he was going to put a chimney and a fireplace on like that. And that concrete as is wet as if you just placed it. It was completely wet and everything like that. I figured, what the heck's going on? So I go back to the plant. Now, these are the old days when all you had was a dot matrix printer, and at the end of the day, you used to press a button on your batch plan, and it printed out a record of everything that you did that day. Every batch came out in mass, whether you wanted it or not. So I'm going back, I'm pulling out delivery tickets and everything like that. His load was right before the load that we caught with the retarder. So obviously, he got a little bit of retarder in it. So I called the guy up and I said, "I got some good news and I got some bad news for you." And I said, "The bad news is I haven't a clue when that concrete's going to set up. The good news is when it does, it's going to be really strong." So cover it up with a piece of plastic, keep it from drying out. And sure enough, a week later, he was building his chimney on top of it. But, those things happen, things like that. So.
That's pretty good. That's pretty good. Josh, I saw you scribbling some notes over there. You got anything for, I guess?
No, I actually wrote down the name of your family company, and that way I'm a little bit more familiar with it. I get around the Lehigh Valley area every once in a while. I actually graduated from Albright in Reading, Pennsylvania. So, yeah, I just was jotting some notes down there. Are you born and raised in that area?
Yep. Yeah.
Okay.
I lived there all my life except 4 years at the University of Pittsburgh. Pennsylvania really should be 2 states, an east and a west, and I've got had a chance to live in both. So
that's awesome. I say that to everybody. Pennsylvania is 2 states because Pittsburgh area might as well be Ohio, and the Philadelphia area might as well be New Jersey.
Yes.
And then there's Harrisburg in the middle with an identity crisis.
Yes, but when you say New Jersey, that can be slightly insulting, so you got to watch that.
Did you say it was the James Carville quote?
Did you ever hear that guy? James Carville had a quote when he was delivering a speech in Pennsylvania about the state. He says, Pennsylvania, it's Philadelphia and Pittsburgh and Alabama in the middle.
I've never heard that.
You know who James Carville is?
Yeah. I can't believe I've never heard that quote before.
When I moved up here, I moved from the South, from Alabama and Georgia and that area, and I come up here and I moved to Pennsylvania, central Pennsylvania, the Alabama in the middle. But when I got here, I said, wow, this actually reminds me of home. Rural people almost talk with a Southern accent, even, it's a slow, small town feel, and I really enjoy it. And that's when I was introduced to the phrase Pennsyltucky.
Yeah.
But
Hills of Pennsyltucky.
we're also a little bit of our history, that we're blessed too, that, like I said, we're the first region in the United States to produce cement. We've got a very strong industrial base and a very strong manufacturing base. And we are the number 2 producer of crushed stone in the United States yet. So, we represent the aggregate industry with a strong aggregate industry in that respect. Very, very technically savvy aggregate industry and a lot of huge producers. And when you don't realize, we right now have 12 underground mines producing construction aggregate from underground mines across Pennsylvania. Yeah, it's moving that way because of the more political acceptance of an underground facility than an above ground facility. And it's purely like that. And again, being blessed with a lot of variation in geology, there's good and bad things that come with that. We have the ability to do that. So you would not know, but there are, 12 underground mines producing construction aggregate in Pennsylvania.
So a bunch of room and pillar type construction for these underground limestone mines. That's cool. Joey, you've been pretty good at being quiet over there. What you got for us?
Thank you, Jim, for coming on. I've learned a whole lot from, being down here in Tennessee. I don't know anything about the goings on up in Pennsylvania, so everything you've said been very informative. But the one takeaway I did get from it was that your inbred elephants comment, I was really hoping it'd be a dig at Alabama football, and was very disappointed.
Sorry, that was self-reflective, so what can I say?
He was saving that for 25 minutes now.
Just to poke at me. This is because I was poking at him when we started up the Skype call an hour ago.
You got your back.
Luckily, I can take it.
Speaking of college football, Jim, are you a college football fan?
Not that much, since we have these 2 very high-profile professional teams, in there, and going to school in Pittsburgh, they really, really love their football. I mean, really love their football, and the same thing can be said about Philadelphia. So, because I went to Pitt, that means I am not a Penn State fan. That means absolutely not Penn State fan.
Yeah, I knew Josh was like that, but it's interesting because, me and Joey, being from the South, we're big college football guys. And then one of the things I always noticed was that Pitt seems to ruin everybody's season.
Yeah.
And I go here, and Josh is actually a Pitt fan. He's like, that's my team in the Big Ten, and they just ruin everybody's life. Or the ACC.
They're ACC.
Yeah, sorry, ACC. And they just ruin everybody's season.
Yeah, they'll be a top 5, a top 10 school every single year, whether they're playing 500 football or not.
Right? Yeah.
Yeah, to lose to James Madison one week and beat Clemson the next week.
100%.
It's incredible.
It is.
Well, did you have anything else you wanted to Jim?
No, I don't. And it's my pleasure. I appreciate the opportunity. Thank you for having me. We so happy to have your company into our association. And we talk a little bit about association work. I was very fortunate in that, I didn't have a choice when I got in the industry. I was told, you go to the association and meetings and you learn. And I was fortunate to be able to do that about 40 years ago when I met some people that I can still call friends today because we're in, like I said, we're very an interbred industry and nobody does this alone. And I mean it's your career. To have contacts across the state that I can reach out and say, hey, what do you think about this? What do you think about that? And again, these are people that I've known for decades, and I'm privileged to have them as my friends. And that's one of the things we can do as the association. And Paul, you noticed that our meetings we had, so we have enough time for everybody to just break up and talk to each other. Because, we spend so much time in our own little industry, you don't get a chance to go out and see and hear what other people are doing. And your strength may be somebody else's weakness and vice versa. And, there's many a times where I reached out to a person in the central Pennsylvania, western PA and say, hey, I got this going on. What do you got going on? And he's seeing the same, or she's seeing the same, or she's seeing something different. And we can put our heads together on that. And just to be able to do that, that's the inherent value that we have. So it becomes great for your company. You can bring stuff great back for your company, but the individual benefits to helping your career you just can't put a price tag on that.
No, well said. And I tell you, I hope to bring something to the organization. In time, I hope that I'll be able to put some of my skills and knowledge and add it to the collective.
All right, we'll love to have you.
Yeah, thank you. Well, appreciate all your time. Thanks again for coming on.
Our pleasure. Continued success with the podcast. I love what you guys are doing, and we'll all keep listening.
All right, sounds great.
Appreciate that.
Thanks, Jim. Right. Have a good evening.
Good afternoon, guys.
All right, that's going to do it. One last final thank you to Jim for coming on the podcast. We really appreciate all the information, insight, stories, background, everything he was able to share. Hopefully you enjoyed it as well. Look out for episode 4 coming out shortly. And until then, take care.